Greetings to you all. It is such an exciting and a wonderful time to come your way once again. We are going to continue with our lessons on circle theory. I'll urge you to get your calculator, your pen, and any other instrument that you need for this section. In our last or previous section, I gave you a question which I asked you to try your hands on them. I'm going to provide you the solution with those questions, and then we are going to continue with theorem 2. During our previous class, I gave you a question. So during our last section, I gave you a question like this, and I asked you to determine the size of angle NOM, and the size of the angle ONM. I also explained to you that circle theorem is always, or it goes in connection with plane geometry. All the plane geometry theorems that you were taught in class are applicable over here. So you should always have them at the back of your mind. Now, under theorem 1, we said we're looking at the connection between the angle subtended at the center and the angle subtended at the circumference. And we established that the angle at the center is twice the angle which is subtended at the circumference. So before you solve this question, first of all, you ask yourself certain questions. Now the question says, LMN is a triangle inscribed in a circle. It is a triangle inscribed in a circle. And we also learned that from plane geometry, angles in a triangle should always give us 180 degrees. When you sum the angles in a triangle up, it should give you 180 degrees. So to be able to get the answer to this question, you realize that the angle at the center here is not given to you. The angle at the circumference here is also not given. But we can easily get the angle at the circumference, which is the angle L. I can get that because the question said MNL is a triangle. So if MNL is a triangle, then sum of angles in a triangle should give us 180. I know the angle at M and I know the angle at N. So it means we can easily get the angle at L. So we first find the angle at L. So I'll say triangle MNL is a triangle. Implies the sum of angles in the so angle MNL plus angle NML plus angle MLN should equal to 180 degrees. And that is sum of angles in a triangle. Now MNL, that is 78. So this implies 78 degrees plus NML. So the angle at M, that is 61 degrees plus angle MLN. So MLN, that is what we are trying to find, this angle. So MLN is equal to 180 degrees. This implies 78 plus 61, that will give you 139 degrees. plus angle MLN equals 180. To be able to find the angle at L, we will take this 139 to the other side. So angle MLN will be equal to 180 minus 139 degrees. I'll give us 41 degrees. So the angle here is 41 degrees. Now you realize from the diagram that we have the angle at the circumference now. Now look at the angle they asked you to find. You are looking for the angle NOM. So NOM. But you realize that the lines that create the angle is not there. So you have to draw the lines yourself. So it is NOM. So join N to O. So I'll join point N to point O, and then point O to point M, so that I can now have the angle NOM. So NOM, so the angle at the center. So NOM is angle at the center. I'm looking for angle at the center. You realize that now we have the angle at the circumference now. So if you have angle at circumference, you are looking for angle at the center, you can always connect the two of them. And we explained that the reason is that the two angles are subtended by the same chord. If you look at the chord NM is subtending O at the center, and the same chord NM is subtending L at the circumference. So there is a connection between the angle at the center and the angle at the circumference. And we established that the connection is that the one at the center is twice the one at the circumference. So I told you that take your time and write it in order as you say it. The angle at the center is twice the angle at the circumference. So which one is the angle at the center? The angle at the center is O. So angle at the center, angle NOM, is, we use equal to, so is twice 2 is twice the angle at the circumference. Angle at the circumference is what we just found, angle MLN. So it's twice angle MLN. MLN is 41 degrees. So angle NOM is equal to twice 41. 2 times 41. Angle NOM will be equal to 2 times 41 will give us 82 degrees. The angle at the center here is 82 degrees. Now the next question asks us to find the angle ONM. I'll follow the points O, N, M. So ONM is this angle, the one here. I want to find this angle. Now the angle we are looking for is part of the smaller triangle over here. And I explained in our previous class that a smaller angle here is always an isosceles triangle. Why do we say it's isosceles? Because we know that for isosceles triangles, always 2 of the length of sides are equal. Now the name for the line ON, we said ON is called a radius. So ON is a radius, and you realize that OM is also a radius. And the radius is always equal in length. Whether the radius is from O to N or is from O to M, it will still be the same length. So the line OM is equal to the line OM. So if ON is equal to OM, then it means that this triangle here becomes an isosceles triangle. So the smaller triangle in here is isosceles. So that for isosceles triangles, we know that the base angles are equal. So if the base angles are equal, if I call this angle here X, then it means that this side will also be X. Now we know all the 3 sides of the triangle. This side is 82, this side is X, and this side is also X. sum of angles in a triangle should give us 180 degrees. So we can use that to find the angle ONM. So let's follow. From triangle ONM, we know that line ON is equal to line OM. So this implies the triangle ONM is isosceles, which we've already done over there. It is isosceles because the two lengths are equal. Now, if the two lengths are equal, then it means that the base angles will also be equal. So we let the base angles, which is angle ONM, equals angle OMN, and is equal to x. So as we've demonstrated in the diagram, we want to use x for the base angles. So we are letting the base angles be x. So this implies 82 degrees plus x is equal to 180 degrees. 82, x plus s will give you 2x is equal to 180. 2x is equal to 180 minus 82. 180 minus 82, that will give you 98 degrees. We want to find x, so we divide both sides by 2. 2 will go into this 49 times. Now for this, if we end on the x, we are not done, because the question did not ask you to find x. It says find angle ONM. But we said ONM is equal to x. So if you know x, then you know ONM. So I'll say therefore angle ONM is equal to 49 degrees. So x, if you find x, you find your ONM. So that was the solution to the assignment I gave to you. Today we are going to look at theorem 2. Now theorem 2 states that the angles a chord or an arc subtends at the circumference in the same segment are equal. The angles a chord or an arc subtends at the circumference in the same segment are equal. So let me write that on the board, then we'll look at the explanation to that. Let's get the explanation to this, then we can look at related questions. So we are saying the angles a chord or an arc subtends at the circumference. So you should subtend the angle at the circumference and in the same segment. So if they are subtended at the circumference in the same segment, then they are equal. They are equal. Now I said we use either chords or arcs, but I will prefer the use of the chord. So let's look at this theorem. Now let's call the center O. Now we are looking at the angle that a chord will subtend at the circumference. So we have to introduce a chord into the diagram. Let me introduce a chord here. We said a chord joins 2 points on the circumference of a circle. So let me call this chord A, B. Now the angle that a chord will subtend at the circumference, the angles, so meaning it can subtend more than 1, 2, 3, 4 in the same segment. We also explained that this chord has divided a circle into 2 segments, so that we have major segment and minor segment. So assuming this chord is subtending an angle at the circumference in the major segment, let me call this angle C. We've already explained the meaning of subtend and how to subtend. I told you that if a chord is subtending an angle, then the lines which create the angle should have a connection with the chord. The lines which create the angle should have a connection with the chord. So you realize that for angle C, the lines that create angle C involves this line and then this line. Now if you look at this line, it has a connection with point A. And then this line also has a connection with point B. So this chord AB here is holding or subtending angle C where? At the circumference. Again, let's look at this. Let me call this angle D. Again, chord AB is holding or subtending angle D at the circumference. It is subtending because the lines which create the angle D has a connection with the chord AB. This line has a connection with point A, and this line has a connection with point B. So AB is subtending D also at the circumference. So one chord AB. One chord, the same chord is subtending C at the circumference. The same chord AB is subtending D also at the circumference. And they are both in the same segment. They are both in the major segment. So because AB subtends both D and C in the same segment, the angle D here will be equal to the angle C. Because it says that the angle that a chord will subtend at the circumference in the same segment are equal. So assuming the angle at D is X, then it means that the angle at C is also going to be X. And the word here is angles. So meaning that as many angles that the chord AB can subtend at the circumference here in the same segment, all those angles are going to be equal. So if the angles were 4, and they are all subtended within this segment at the circumference, then all those 4 angles are going to be equal. Let me use one more example to buttress the point. So again, assuming we have this circle, we have a chord here, PQ. Now let's look at this diagram also. Now if we are looking at the chord PQ, PQ is a chord because it joins the point P to the point Q on the circumference. So PQ is a chord. Now you realize that the chord PQ here is subtending angle T at the circumference. Why is it subtending T? Because the angle T here, you realize that the line which creates the angle T, this line, has a connection with the point P, and this line has a connection with the point Q. So PQ is subtending T where? Look at where T is subtending. It is at the circumference of the circle. Again, if you look at the angle S, for angle S also, this is the angle S. The lines which create the angle S, involves this line and this line. So the two lines which create the angle S also have a connection with the chord PQ. So PQ is subtending S also at the circumference. Again, the same PQ is subtending angle R also at the circumference. So you realize that chord PQ is subtending three angles: angle R, angle S, and angle T. And they are all subtended at the circumference of the circle. And they are all in the same segment, in this segment. So because they are all subtended at the circumference in the same segment, it means that all the three angles here are equal. So if this angle here is A, then it means angle S will also be A, and angle T is also going to be A. So the angles that a chord or an arc subtends at the circumference in the same segment are equal. It doesn't matter the number of angles, if they are 10, 20, so far as the same chord is subtending all those angles and they are the circumference within the same segment, then all the angles are going to be equal. Now let's look at a related. In the diagram below, O is the center of circle WXYZ with angle WXZ equals 72 degrees. What is the value of angle WYZ? What is the value of angle WYZ? So before you solve the question, don't be in a haste. Take your time and study the question very well. Now, we've learned on two theorems now. The first theorem is the connection between the angle subtended at the center and the angle subtended at the circumference by the same chord. We're saying that the angle subtended at the center is twice the angle subtended at the circumference. But in this question, you realize that you are not looking for the angle at the center. Rather, it says find the angle WYZ. Now, angle WYZ, follow the points to look at the angle that you are looking for. Remember that I said when an angle is written like this, the angle is the one in the middle. So we follow the points WYZ. So that is the angle over here. I want to find this angle. I'll ask myself, what is the angle Y? You realize that angle Y is the angle subtended at the circumference. But which chord is subtending the angle Y is very relevant. Look at the chord that subtends the angle Y. So I will follow the lines which create the angle Y to know which chord is subtending angle Y. Now the lines which create angle Y involves this line and this line. So if I follow this, angle Y here has a connection with point W, and I'll follow this one also. This line also have a connection with point Z. So you realize that chord WZ is subtending Y at the circumference. Again, you realize that the angle X here is 72. I'll look at which chord is subtending angle X. Now if I follow the lines which create angle S, it is this line. It has a connection with the point W, and I'll follow this line also, and it has a connection with the point Z. So WZ is subtending X at the circumference. So you realize that one chord is subtending two angles at the circumference. One chord called WZ. This WZ here is subtending angle X at the circumference, and the same WZ is subtending angle Y also at the circumference. The theorem 2 is saying that the angle that a chord will subtend at the circumference in the same segment. You realize that all these angles here are in the major segment. So WZ is subtending X at the circumference. The same WZ subtends Y at the circumference. So it means that this angle here is equal to this angle. So this is just a two-step solution. So I will say WZ is a chord. WZ is a chord, implies that angle WXZ is equal to, they will be equal because they are subtended at the circumference by the same chord. So it will be equal to angle WYZ, and it's equal to 72 degrees. Therefore, my angle WYZ is equal to 72 degrees. So this angle here is also 72. And the reason is what I just gave. The theorem 2 explains that if a chord subtends two angles at the circumference in the same segment, then those two angles are equal. So angle X is equal to angle Y. Under circle theorem, the theorems will not stand idle on their own. Usually you find a combination of 2 or 3 of the theorems in one question. So because we have completed with theorem 1 and theorem 2, I'm going to combine question to relate the theorem 1 and then the theorem 2, and then we see how we can work or solve such questions when they are being asked in any exam. So we are going to look at the theorem 1 and theorem 2 combined in a question and how to deal with it. Okay. Now this question says PQRS are points through the circle center O in the figure above, and angle PQR equals 48 degrees. Find I, the value of angle ROP, II, the size of angle PSR. So we are going to take them one after the other and try. 1. Remember that we've learned on only 2 theorems. We've learned on theorem 1, which connects the angle subtended at the center with the angle subtended at the circumference. And we've learned on theorem 2, which is angle subtended at the circumference by the same chord. So we look at the angle we've been asked to find, and that will guide us as to how to get our solution, whether we have to use theorem 1 or whether we have to use the theorem 2. Now the I part of the question says find a value of angle ROP. So again, we will follow these points to look at the angle we are looking for, the angle O. So I'll come to the diagram. This is R, this is O, and this is P. So ROP is this angle. I'll ask myself, what is this angle? This angle is the angle subtended at the center. Now I'll look at the connection between the angle at the center and the angle at the circumference. Now, to get the angle at the center here, which chord is subtending this angle at the center? To get a chord which subtend the angle O at the center, I have to follow the lines which create the angle to know which chord is subtending that angle. So the 2 lines which create angle O involves this line and this line. So if I follow this line, it has a connection with a point P. And if I follow this line here, it has a connection with a point R. Now you realize that this PR here, though it's a chord, the line has not been joined. So you can use dotted lines or broken lines to join the chord, the point P to the point R, to form the chord. So that you can now see that the chord PR subtends angle O at the center. Now chord PR subtends O at the center. Let's look at the other angles that chord PR subtends. Now look at the angle S. For angle S, you realize that this line here has a connection with point P. This one also has a connection with point R. So PR subtends S at the circumference. Let's look at the angle Q also. For angle Q, this line has a connection with point P. This line has a connection with point R. So PR subtends angle Q also at the circumference. So you can see that chord PR is subtending 3 angles. PR is subtending O at the center, PR is subtending S at the circumference, and PR is subtending Q also at the circumference. Now we explained from theorem 2 that the angle that a chord will subtend at the circumference in the same segment are equal. So this angle here is 48. It means that the angle at S will also be 48 degrees. Now, this one is the angle at the center. Now, I have 2 angles at the circumference. I have this and I have that. So I can use any of these 2 angles to find the angle at the center. Remember that the angle at the center is twice the one at the circumference. So angle at the center O, look at the chord PR, it is subtending S at the circumference. So the one at the center should be twice the one at the circumference. So if the one at the circumference is 98, if we multiply 98 by 2, 48 by 2, we are going to get 96 degrees. The same way, I can also connect the angle at the center here and the one at the circumference here, and the answer will be the same. Let's check that. Remember that PR is subtending O at the center, and the same PR is subtending Q at the circumference. So the one at the center here is twice the one at the circumference. So if this one is 48, I multiply 48 by 2 and I'm going to get 96 degrees. So whether I use the connection between the one at the center and the one at the circumference here, or I use the angle at the center and the one at the circumference here, the answer will always be the same. Now, as a first rule, anytime you have theorem 1 and theorem 2 in any given question, when you add the two angles subtended at the circumference, it should always give you the angle at the center. So if I add these two, it will always give you the angle at the center here. There is an objective question on this which we'll look at later in one of the past questions. So anytime you have theorem 1 and theorem 2 combined in a question, when you add the two angles subtended at the circumference, it should give you the angle subtended at the center. So you realize that when you add 48 plus 48, it will also give you the 96. Okay, so now let's look at the answer. We've already solved, but let's now look at how to present it for the examiner. So the value of angle ROP. Okay, so to get our ROP, first we went to look for the angle over here. So we can also connect it directly, this and that. So let's use the connection between the angle at the center and the angle subtended at the circumference. So angle ROP is twice the angle at the circumference. So twice angle PQR. Angle ROP will be equal to twice angle PQR is 48 degrees. Angle ROP will be equal to 96 degrees. So this angle here is 96. The next question says we should find the size of angle PSR. PSR. So follow the points. Point P, point S, point R. So that is the angle at the circumference here. And I've already explained that. Chord PR is subtending Q at the circumference. The same PR is subtending S also at the circumference. So the angle, that is theorem 2, the angle that a chord or an arc will subtend at the circumference in the same segment are equal. So this one is 48, means this one will also be 48 degrees. So our II, this was solution II. I know angle PQR is equal to angle PSR and is equal to 48 degrees. Therefore, angle PSR is equal to 48 degrees. The angle a chord or an arc subtends at the circumference in the same segment are equal. So we have been able to look at theorem 2 for today's lesson. I would want you to have enough time to study the theorem 1 and the theorem 2 well. You can look through your past questions, and there are textbooks as well to assist you to go through some of these questions. So please, whilst you are home, get some of the textbooks and look at some of the questions that we've done on this. In our next class, we are going to look at theorem 3. I've told you we are going to study 9 theorems. So in our next class, we'll look at theorem 3. Then after going through theorem 3, we'll look at how to combine theorem 1, theorem 2, and theorem 3 in a question. I don't want us to rush through the theorems. So I want to take them bit by bit and have time to go through each and every theorem with you. God richly bless you for your time with me today. Ladies and gentlemen, that brings us to the end of the entire caboodle. Please make sure you stay at home and stay safe. God bless you once again. Bye-bye.